Welcome to the video on scientific notation. The SOL objective for today is that the student will determine scientific notation for numbers greater than 0. At the end of this video, you should be able to say that you can convert numbers written in scientific notation to standard form by moving the decimal to the right for positive exponents and to the left for negative exponents. Let's take a look here at JZ. This is how much JZ is worth, 3.4 times 10 to the 7th power. Now what I want to do is take a look at this number and talk about what we already know. We've already learned our powers of 10, right? So we already know that part. Now what is 10 to the 7th power? Well, we learned that the pattern for tens is that you have how many ever zeros that the exponent is. So we have 7 zeros here. So JZ is worth 3.4 times, whoops, comma in the wrong place, times 10 million. All right, so now we could say 3.4 times 10 million, okay? But what I'm going to do in this video is I'm going to show you another way to figure out how much this is. So let's take a look at this. This is an amoeba, okay? An amoeba is super tiny. It's microscopic. We need a microscope to even see it. So rather than writing a decimal and all these zeros and then showing a number that's super tiny, scientific notation gives us another way to write it. But again, I want to talk about what we already know. We already know that 10 to the negative 4th means that we have 4 zeros, but that the number is less than 1. So we have 0, 0, 0, 0, 1. And the decimal is always after the first 0. All right, so this would be 5 times 0.0001. All right, let's take a look at some really big numbers, why we want to use scientific notation. So this is the distance between the Earth and the Sun. As you can see, those are some really big numbers. If I put some commas in here, all right, we have 150 trillion. So 150 trillion meters, wait a minute, hold on, wait, billion, millions, billions, I'm sorry, 150 billion meters are 1,500,000,000 kilometers. That's the distance from the Earth to the Sun. Those are huge numbers. All right, here's some more. The distance to the next closest star. So we have Alpha Centauri. All right, these are really big numbers. It's too big for us to even comprehend. So that scientific notation gives us an easier way to write these numbers. So let's take a look. Which would you rather read? Would you rather read one of these, or would you rather read 1.5 times 10 to the 11th power? That's much easier to read. All right, so what I want you to do here is pause the video and copy your notes. Okay, so what I'm going to do is go ahead and go over these notes. Numbers can be written in standard form and in scientific notation. Standard form is the way that we've always looked at numbers. So this here would be standard form, or we can write them in scientific notation. These two numbers are the exact same, they're equal, but one is easier to read. So 5.2 times 10 to the 12th power is easier to read than the other number, which we have to the trillions place, 5,200,000,000,000. Numbers written in scientific notation are made up of 3 parts. We have the coefficient, the base, and the exponent. So this first part here is the coefficient, and it must be greater than or equal to 1 and less than 10. So that means this place right here has to be between a 1 and a 9. Okay? So for a number to be written in scientific notation, we cannot have a 0 there, and we cannot have, say, a number right there. It's got to be between 1 and 9. Now we can have numbers after the decimal. We can have more than one number after the decimal. We just can't have more than one number before the decimal. All right, then we're going to say times 10. The base is 10. It's always 10, okay, to some power. And in this case, it's to the power of 12, which is our exponent. The exponent shows the number of decimal places that the decimal needs to be moved to change the number to standard notation. So if it's positive 12, we're going to move the decimal 12 places to the right. If this was negative 12, we would move the decimal 12 places to the left. So this says here, a negative exponent indicates that the decimal is moved to the left when changed to standard notation. So that does not mean that our number is negative. So if I say 5.2 times 10 to the negative 12, our number is not negative. That just tells us that the number is less than 1, just like negative powers of 10. So scientific notation is used to help us write numbers that are huge and that are tiny. All right, so let's go ahead and take a look at your notes. We are going to fill these in. So it says the exponent, tells you how many places you will move the decimal. So that space up there should say decimal. Let me get this out of the way so I can write that. All right, so we're going to move the decimal right if the exponent is positive. So an example would be 1.5 times 10 to the third. So we move the decimal to the right. We're going to move the decimal to the left if the exponent is negative. So 1.5 times 10 to the negative third. And now what we're going to do is we're going to go ahead and do a couple of these examples together, and then I'll have you pause the video and try a few. So let's look at the first one. The first one is 3.042 times 10 to the second power. The exponent tells us how many places to move the decimal. So we're going to move it 2 places. So 1, 2. So that means my decimal is going to be between the 4 and the 2. So my new number is 304 decimal 2. So I have 304 and 2/10. All right, let's look at the next one. I have a positive 4. All right, so I'm going to move the decimal 4 places. So it'll be 1, 2, 3, 4. Now notice there's nothing in these little humps here, so I got to put zeros there. So I'm going to do 6, 1, 0, 0, 0. And my decimal here is at the end. Because it's at the end, I would not need to add that decimal. I'm just showing you that for demonstration purposes. All right, let's take a look at another one. I have 1.05 times 10 to the second. So I'm going to move the decimal 2 places. So this would be 105. And again, the decimal would be at the end, but I don't need that. Okay? Now what I want you to do is pause the video and you try the next 2. Okay, welcome back to the video. What I've done here is on the first one, okay, right here, the first one you were supposed to try, I moved the decimal 3 places to the right. The decimal ended up between the 4 and the 6, so I rewrote it with the decimal between the 4 and the 6. The next one I moved it 4 places, but I only had 3 numbers here, so I had this extra hoop here. So what I did was I put a 0 in the extra space. All right? If you have any questions, please go ahead and write those down now. All right, let's go ahead and look at negative exponents. This one is a negative 3. So I'm going to move the decimal 1, 2, 3 spaces to the left. And I've got to put zeros in these spaces. So I'm going to always put a 0 out in front before my decimal. That's a requirement. So it's 0.00963. Now that 0 out in front does not change the value at all. It's just, we're just required to put this 0 here. It's a placeholder. All right, let's take a look at the next one. We have negative 2. So this one we're going to move 2 places. 1, 2. Again, we put a 0 there. So it's going to be 0.09105. Okay, let's take a look at the next one. The next one is a negative 1. We're going to move it only 1 space. So we're going to do 0.29854. Okay? Now what I want you to do is go ahead and pause the video here and you try the next 2. All right, so here, the next one, I have 6.5 times 10 to the negative 5th. And then I have moved the decimal 5 spaces to the left because it's negative. So 1, 2, 3, 4, 5. And then I have I moved it 5 spaces. So I'm going to rewrite my number with the decimal out in front of that 4th zero there, or the first zero. All right, and then the next one is 10 to the -1, so I'm only going to move it 1 space. So it's 0.98. Now, you can always check your work by doing 7.259 times 10,000, because remember 10 to the 4th power has 4 zeros, and then I could check it to make sure I got it right. Over here, I could check it by saying 9.8 times 0.1. And the -1 tells us that we have 1 0. So it is less than 1. Go ahead and pause the video here if you need to. Oops, wrong way, sorry. Alright, so what you should be able to say at the end of this video is that I can convert numbers written in scientific notation to standard form by moving the decimal to the right for positive exponents and to the left for negative exponents. If you have any questions at all about this, please jot those down in your notes so that we can talk about them next class.